Okay, next topic is called variation. So, variation is a relationship between two variables. So, y and x may be, say, our two variables that we're looking at. Could be anything, of course, but variation tells us how those two things are linked. So one of them will change, say like x, that'll change in some way, and so then y would change as a consequence of x changing, and that's kind of variation. So if you change by the same factor, looking by factor change, then it's going to change by the same amount each time. Alright, so there's a few different types of variation, and first one we're going to look at is direct variation, and things can directly vary in a number of different ways. So let's have a look, say, at this one here. So let's say number of hours, money raised, right, so the number of hours, call that N, amount of money raised, we'll call that C. So for 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours, we're doing whatever this thing is. So we might get $1.20, $2.40, $3.60, $4.80, and $6. Alright, so variation has a look. So if we look between say 1 and 2 hours, we're multiplying by 2 here, and in this case here we're multiplying by 2 the money raised. If we're saying looking from and so then we go, say, from 2 to 4, that's multiplying by 2, and then have a look here, 240 to 480, again that's multiplying by 2. And another look, if we go from here to here, that's timesing by 3. Here to here, that's timesing by 3 also. So this is an example of direct variation. So direct variation is, so doubling one variable results in the other. Doubling. In this particular case, there can be other kinds of direct variation, and we'll get to those a little bit down the track, but so this is the simplest. So the way we can write that, well, if I graph that, let's have a look at a graph of it to start with. So if we graph that, and then we've got 1, 2, 3, 4, 5 hours, that's our N. And up the top here we've got our 120, 240, 360, 480, $6. And if we put in our points, right, and then you get a straight line out of it. Okay, so that's another thing we can look at with direct variation. So direct variation, and I forgot to put money raised. Okay, so with our direct variation, when you look at our our two variables there when those two things are directly related to each other if we get a straight line graph. So, in this case, money raised is proportional to the number of its direct variables to the number of hours. Okay, so how do we write this? Well, we can write as that C is directly proportional to N. C varies directly as N. And mathematically, we would say that C proportional to N. So that symbol there, that symbol means, these two things. That symbol represents those. Now we can go further because when you look at your graph here, straight line graph, so we kind of have a gradient here of that straight line graph, so we can go a bit further, and in this case for variation we use the letter K. So we can go further than that, and so if C is proportional to N, that means C is equal to K times N. So again, the equals K replaces that proportional sign. So therefore, in general, Y is proportional to X, then Y equals Kx. Where K is the constant of variation, and also K is an element of the real numbers. Now, this word variation proportionality is another word that we can see. So those two words there are interchangeable. Okay, so let's have a look at some examples. So first example is for the given data, find if direct variation exists. All right, so here's our information. So we've got X values, we've got Y values, and so X is 4, 7, 8, and 10, we don't need that last one, and we've got 5.2, 9.1, 10.4, and 13. Now, if Y is proportional to X, then Y equals Kx. And so from that, we can say when we rearrange that K, by dividing by X, both sides, that K would be Y on X. So if we do that, and we do that divided by, so 5.2 divided by 4, you get 1.3. Okay, so now if this is direct variation, then we should end up with 1.3 for all of those. So we just need to check that. 9.1 divided by 7 comes out to 1.3. 10.4 divided by 8 comes out to 1.3. And finally, 13 divided by 10 is 1.3. So in this case, direct variation exists. Now we could have also established that if we wanted to by drawing a graph. If we draw an accurate graph and that graph's a straight line, then direct variation exists. Okay. Next example. If it is known that m is proportional to n, so direct variation exists there, find A, the constant of variation, and secondly B, the missing values. In this table, so we've got an N, we've got an M. There they go. We got 3 here, we got 6 here, we got 9 there, we got 10 there, we got 18 there, and we got 20 here. Okay, so the bit that's going to help us is going to be this one here, because we know we're told that m is proportional to n, which leads us to saying that m is equal to k times n, which leads us to k being m divided by n. And so when we do that, k will be 18 divided by 9, which is 2, so we now know that m equals 2 twice n. And we can use that. So first one here, when n is 3, 2 3s is 6. This one here to get m, well if m is 10, what do you need to multiply by 2? You need to multiply 5 by 2. 2 6s are 12. And again, what do you need to multiply by 2 there? You need 10. So there's our solutions there in that table. Very quickly. If you're not sure about the mathematics, arithmetic stuff that I did in my head, let me know. Alright, one more example. Okay, so the distance travelled varies directly as time, and it is known they travelled 12 kilometres in 2.5 hours. Find. Okay. First A, how far in 3 hours? And B, how long to travel 6.72 kilometres. Okay, so solution. Okay, so distance varies directly as time. So the distance varies directly as time, which leads us to the distance is k times time. So if we could find out what that was, that'd be really, really handy, because then we could use it to find parts A and B. So at the moment, it's 12 kilometres in 2.5 hours. So from that, we can get that K would be equal to the distance over the time, and the distance is 12 and the time is 2.5, and so replacing D and T, and so K, our constant of proportionality for this particular thing, is 4.8. So we know then that the distance equals 4.8 times the time. So the first one here, how far in 3 hours? That's 4.8 times 3, which when we put that in, we get 14.4 kilometres. And this one here, how long to travel in that? So 6.72 equals 4.8 times the time. Dividing both sides by 4.8 then gives us 1.4 hours. I think it's in hours. Yeah, well, it's in hours. I paraphrase this from the book, so I forgot to add that in. Of course, hours needs to be changed. Right, this is one of the things that, how you represent your results. So 1.4 hours needs to be into hours and minutes. Okay, so it's 1 hour plus 0.4 of an hour of 60 minutes. So it's 1 hour and 24 minutes for our answer to that. Okay, why do we need to do that? Well, it's the normal way we talk about hours. We don't talk about 1.4 hours. We might talk about 1.5 hours, but not 1.4. We'll be talking 1 hour and 24 minutes. All right. Okay, so that's it for your direct variation. So that's exercise 7A, set 1 of your direct variation sheet.